everyone. I am Amruta. Today's topic first come first serve scheduling, design and evaluate under the guidance of Sumana ma'am. Introduction. CPU schedules decides which process gets the CPU next. The operating system uses the scheduling to select which process should run on the CPU. This helps the manage multiple processes efficiently. FCFS is the simplest scheduling algorithm that follows the order of the arrival. Here assis- it assigns the CPU to process in the exact order they arrive. Works like a queue, the first process that comes in the first to be executed. It works like a normal queue system and is easy to understand. Here, no complex logic or a priority required, just follows the arrival time, can lead a long waiting time if the long process comes first. Experimental setup. The language used is C. C program language is used to implement all the CPU scheduling algorithm. The compiler, online C compiler, the programs are executed using an online C compiler for a easy test and a verification. Inputs: arrival time and burst time. Arrival time, the time when the each process enters the ready queue. Burst time, the total time required by the process for the execution. And the outputs: completion time or finish time, waiting time, total turnaround time, response time. First, the completion time, the time when a process finishes the execution. Turnaround time, total time from the arrival to completion. And waiting time, time process spends waiting in a ready queue. Response time, time from the arrival until the first CPU allocation. An algorithm compared first come first serve, shortest job first, shortest remaining time first. Here, if first come first serve is the simple non-primitive executes in a arrival order. SJF picks the process with the shortest burst time, lower waiting time but non-primitive. SRTF is a primitive version of a SJF, always chooses a process with the least remaining time. Implementation steps. Input the number of a process. The user enters how many process will be scheduled. Enter a arrival time and a burst time for each as the inputs. Sorts a process according to selected scheduling. Process are arranged differently for the FCFS, SJF or SRTF according to their rules. Then calculate the completion time, turnaround time and a waiting time when the process is finished. Then generate the Gantt chart for the process execution. Shows the execution order timing for each process. Flow chart. Starts. The algorithm begins. Input number of a process n. User enters how many process need to be scheduled. Read arrival time, burst time, process ID for each process. For each process, the program takes arrival time, burst time, process ID. And the fourth steps: sorts process by the arrival time. Processes are arranged in the order they arrive. Requires for the first come first serve. Checks if the CPU is idle. If the current is greater than 80, where CPU waits until the process arrives. So current time is equals to 80. Calculate the time, current time plus burst time. Calculate the turnaround time, completion time minus uh, arrival time, calculate the waiting time, turnaround time minus burst time, update the current time C, then it checks if all the process are done. If not, repeat the step for the next process and end all the process are scheduled or completed. Here it is the code for first come first serve in C programming. Enter the number of process 4. Arrival time for P1 is 2. Burst time for P1 is 6. Arrival time for P2 is 5. Arrival time burst time for P2 is 2. Arrival time for P3 is 1. Burst time for P3 is 3. For P4 arrival time is 0 and the burst time is 4. Here the process ID, arrival time, burst time, to complete time, to turnaround time and waiting time. Average waiting time 4 4.00. Average turnaround time 7.75. Gang chart. It shows the CPU execution order like P4, P3, P1, P2. For P4 runs 0 to 4, P3 runs 4 to 7, P1 runs 7 to 13, P2 runs 13 to 15. Each block shows when a process starts and a finish. Observation. Time from process arrival to completion. Total time from when the process arrived to when it's finished. For waiting time, time a process spends waiting in a ready queue. Number of context switches, count of CPU switches between the process. Number of times CPU switches from one process to another process. CPU utilization, percentage of a time CPU is actively executing a process. How the efficiently the CPU is used. Here the formula for CPU utilization, total busy time divided by total time into 100. Comparison. Algorithms are first come first serve, shortest jobs job job first, and SRTF shortest remaining time first. First come first serve. High waiting time and high turnaround time. Very few context switches. Simple but suffers from the convey effect. Depends on the arrival order. Shortest job first. It is also called as a non-primitive. Low waiting time and low turnaround time. Few context switches. Efficient when the burst time are known but may causes a starvation. SRTF is also called as a primitive SJF. It has a very low waiting time and the turnaround time, high context switches, best performance but higher overhead and a starvation risk. At last, the conclusion, first come first serve is a simple but not suitable for a real time or a time critical task. It is a very simple but not good for real time tasks. SJF reduces the average waiting time but cannot a primitive prompt running process. Here the low waiting time but cannot interrupt a running process. SRTF gives the best overall performance but all causes more than context switches. Best performance but has a many context switches. The best scheduling algorithm depends on the system's requirement and the overload types. Here the choice of a algorithm depends on the system needs to workload type. Thank you.